to start. So we've identified where the roots are. That gives me a factor of x plus 3. The second one's going to give me a factor of x plus 1. And the third root at 4, 0 is going to give me a factor of x minus 4. So by identifying where they are, they tell me all of the factors of my root, of my polynomial. Step 2 is what kind of root are there? There are 3 different types of roots. Now, these are names that I give. The book calls them something slightly different, and I'll touch on that because they call them touch roots. And also there are, a college professor might call them something else. I call them bounce, flat, and cross. So the type of root in this case is a bouncing root. And I call it that because it touches and it goes right back the other way. Your book will call those a touch root, where it touches the axis, but it doesn't cross the axis. Then we have roots like this one, just passes straight on through, like railroad tracks, straight through. We call these a cross root. It just crosses the x-axis, do not pass go, do not collect $200. And then the third type is this type right here, which I call a flat root. It's technically an inflection point. An inflection point is a very, very important point, especially in calculus. You will learn how to find them. And that's where concavities changes. So notice up till here, it's like it's opening down like a frown. After that point, it's opening up like a cup. Okay, so that's why it's called an inflection point. What's happening, how it opens is changing. So my first root is a bounce root, then a cross root, then a flat root. Now you don't have to make a table. I'm just trying to help people see these connections. The type of root then tells me what the exponent on my factor is, okay? So a bounce root looks like a parabola, doesn't it? That means it's going to have an even exponent, 2, 4, 6. For our purposes, we generally just go with 2, but it could be 4, 6, 8, 104. As long as it's an even exponent, it will create that touch and go bounce root. Cross roots only are created with an exponent of 1, which means we don't even write it. It's 1, but it's invisible because why would we say to the first power? That does nothing. Flat roots all have odd exponents. We generally just use 3 because that's the basic, gets the idea of cross, but any odd other than 1, 3, 5, 7, 9, 11, 101, doesn't matter. It's going to have that odd exponent. And anytime a factor has an odd exponent, you're going to have a flat root, an inflection point at the x-axis. Questions on that? Now, so I can start to write my equation now, since I have all this written down. I'll do it down here, and then we'll talk about end behavior. So we've got f of x equals something. I've got some a value out front times x plus 3 squared times. I had a lot of people adding factors together. Once again, go back to quadratics, go back to your parabola. You're not adding the factors, they're multiplying each other, which is why the zero product property works. X plus 1 and x minus 4, and I'm going to go cubed to keep it at the basic level, okay? Now, I put the factors in this order, and that's the order I generally want you to use on formative, but it doesn't matter what order they're in. This is just kind of easier to copy, easier to write. The only exception to putting it in this order from left to right, like I just did, is if you have a root at 0. If there's a root at 0, which there isn't in this case, then my factor would be x minus 0, which is the same thing as just an x root. If there's an x factor, then you would put that out front. because otherwise, if you have it in the middle, it looks like you're multiplying. You know, X looks too much like a time symbol. So we usually move the X out front. The other common mistake I see is that students want to put an X on it no matter what. Shouldn't there always be an X out front? No, 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 no. Only an X when there is a root at 0, 0, thus an X minus 0 factor. It's not like Portland put a bird on it. You don't just put an X on it, okay? X is only there if it goes through the origin, so don't forget about that. Okay. Questions, comments, or concerns before we talk about A? Okay. The last thing that we did a lot in Algebra 3-4 was then I, at the C level, let people just make up an A value. Doesn't matter, just make it up. What's it going to be? Because notice there, this one has Y's, but a lot of times I didn't even put Y's on it. Now, A is going to be positive or negative depending on end behavior. What's happening as X approaches infinity? As X gets closer and closer to infinity, what is happening to Y or f of X? In this case, it's getting bigger, 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 bigger forever. So f of X is also approaching infinity. It ends up. So therefore, my A value has to be positive. So you can put any positive number here you wanted, C level, Algebra 3-4. So 2, 9, I don't care what the number, 1/2. As long as it's a positive number, that could be correct. Here, we are going to find exactly what A is. In order to do that, we need one point on the graph, which is not a root, okay? Can't be a root because we've already used those here, and it's just going to wipe everything out because it's going to make it 0. We know when X is -3, Y is 0. So that doesn't give us enough information to then solve for A. So the point we were given is the point -2, 45. This point is an X and a Y or an f of X. So to solve for A, that's our goal here. There's an A multiplier out front, a coefficient. In order to solve for this, we are going to replace every X with -2 and replace f of X with 45. Questions on that? Okay, now it's just a matter of order of operations. Now, one thing, when you're solving for A, don't just move stuff side to side. Just kind of solve one side and then isolate A. So I'm just going to leave A here. So -2 plus 3 squared, -2 plus 1, and -2 minus 4 cubed. Order of operations says inside parentheses first. So -2 plus 3 is 1, -2 minus 1 or plus 1 is -1, and -2 minus 4 is -6, and that one's going to be cubed. Okay, keep going. Exponents next. 1 squared is 1. Then I got a -1, and then -6 cubed is -216. So this is going to multiply to be positive 216. Okay. Now, common problem that I see students make, common mistake with this, is they then want to subtract the 216. Don't do it. So remind yourself when it's multiplying, it's a lot easier if you then just reverse the order. Okay, 216 times A. So we're going to divide both sides by 216. So A is 45 216ths, which simplifies to 5/24. Then I just go back and write the equation. 5/24 is my A value, so I replace A, and everything else is still as it was. Okay. That was a recap of basically everything